Hello students, welcome back to Diksha Vedantu English for 9th and 10th. I'm your chemistry master teacher Ankitha. Today we are going to discuss a very important chapter just under 30 minutes. So which is that chapter? The chapter is chemical reactions and equations. So this is the very first chapter in your science syllabus. So we will be discussing that this under 30 minutes, just 30 minutes. So let's get started. Before that, let me remind you to subscribe to the channel Diksha Vedantu English for 9th and 10th and turn on that notification button to get notified whenever we upload any videos or whenever we come live. So let's get started. First of all, chemical reaction. So what is a chemical reaction? Chemical reaction, a process in which one or more substances. So what are these substances? These are the raw materials, okay, in general sense. These are the reactants that are converted to one or more different substances. These are called the products. Products are the new substances. What are products? Products are the new substances. Okay, substances are either chemical elements or compounds. So the old substances are called products, reactants, okay? And the new substance is the product. New substance is the product. So what's going to happen here? What's going to happen? Rearrangement of atoms is going to happen. Atoms are neither created, mass is neither created nor destroyed during a chemical reaction. But what is going to happen? Rearrangement is going to happen. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as products. A chemical equation. So we are going to represent a chemical reaction using chemical reaction. Chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formulae, wherein the reactant entities are given on the left hand side and the product entities are given on the right hand side. So LHS, okay, in LHS what are we going to have? We are going to have reactants, and in the RHS, right hand side, we are going to have products. How do we represent a chemical reaction? So this is a very simple, general reaction. A plus B is going to give C plus D. Okay, these are the products. A, B are these are the reactants. These are the reactants. All right, a chemical equation. So we are going to discuss more about chemical equation. Moving on. So sodium hydroxide, representation of a chemical reaction. So how sodium hydroxide reacts with potassium nitrate to form sodium nitrate and potassium hydroxide. So this is a word equation. So they have described this in word. So how do we write it? This is a word equation. We are going to write sodium hydroxide. This is one of the reactants plus potassium nitrate. If there are more than one reactant, we are going to separate them using plus symbol. Okay, we are going to use plus symbol. Next, arrow mark. These are reacting to give products. So which products? Those are sodium nitrate, and we have potassium hydroxide. Here there are two products, that's why we are separating them using plus mark. Okay, potassium hydroxide. So this is a word equation. But it is, it is not giving more information to us. What are we going to do? We are going to write an equation now. Okay, chemical equation. What is the formula of sodium hydroxide? NaOH. What about potassium nitrate? KNO3. Okay, it is KNO3. Leading to the formation of sodium nitrate, NaNO3 plus KOH. Okay, so this is the reaction. So this is the chemical equation. All right, so this is the chemical equation. This is the word equation. This is the chemical equation. So this chemical equation is predominantly used. Why? Because it gives more information. How can it give more information? So we are going to represent, reactants and products and their states as well. And if there is a reaction that's happening at a certain temperature or pressure condition, we are going to write that on top of the arrow mark. Okay, so in the bracket, if we represent this, so it means that it is aqueous, it is dissolved in water. Al means it is dissolving alcohol. If we represent small l, it means it is a liquid. Okay, so small s, it is a solid. The substance is the chemical is a solid, and we can either represent by upward arrow mark for gases or small g, okay, represents gas. Downward arrow represents precipitate. Precipitate are nothing but the insoluble solid substance that is produced during a reaction. So a chemical equation gives more information. All right. Moving forward, balanced chemical equation. What are balanced chemical equations? Balanced chemical equations are those which obey the law of conservation of mass. The law of conservation of mass. Conservation of mass. So this is something that you have studied in your 9th grade. What have you studied? The law of conservation of mass states that during a chemical reaction, mass is neither created nor destroyed. Neither created nor destroyed. This is nothing but balanced chemical equation. Is nothing but balanced chemical equation. Okay. So LHS is equal to RHS, or in other words, the number of atoms of each element present in the reactant side, that is left hand side, reactant side, is equal to the number of atoms of each element present in the product side. Elements present in the product side. This is nothing but balanced chemical equation. Are there unbalanced equations? Yes, there are unbalanced equations. But in the examination, or whenever you are writing a chemical equation, you need to make sure that it is balanced. That's super important. Okay. So unbalanced equations are also called skeletal equations. Unbalanced equations are also called skeletal equation. So, as I was telling you, whenever you see an unbalanced equation, you need to balance it. And what are the steps that are required to balance a chemical equation? Let's see. So, the first thing first, you need to write the correct skeletal equation. Okay. Writing the correct skeletal equation is the key. Okay. First thing, so write the correct skeletal equation. Writing the correct skeletal equation means you have to write the correct chemical formula, correct chemical symbols there. For example, sodium nitrate, it is NaNO3. If you write Na2NO3, it's wrong. Okay. So it is giving NaNO2 and O2. You can clearly see here that the number of atoms of each element in the reactant side is not equal to the number of atoms of each element in the product side. For example, sodium is 1, here also sodium is 1. Nitrogen 1 more. But oxygen here 3, here there are 4 oxygen atoms. So we need to balance this. Second thing, so make a list of all the elements in the reactant side and product side. Reactant and product side. And count it. You can either use a tabular column like this. Okay. So this is pretty easy to do. Okay. How do we do that? Reactant side, product side. So sodium, nitrogen, oxygen. In the reactant side, there is only 1. In the product, 1. Nitrogen, 1 each. Oxygen, 3 here and 4 on the product side. So next, what do we need to do? Consider the compound with highest number of atom. Highest number of atoms and balance the other. Balance the other. In here, this has the highest number of atoms. We need to keeping this in mind. How are we going to do that? So NaNO3, we are going to multiply NaNO2 by 2. Okay. When we do that, so what's going to happen? NaNO2, 2 Na here in the product side. Nitrogen, 2 here. Oxygen, 2 2s are 4. 4 plus 2, it is 6. Multiplying NaNO3 by 2 now. So what's going to happen? 2 Na in the reactant side. Nitrogen, 2. And 3 2s are 6. 3 2s are 6. Everything is balanced. It's very simple. Right? So there is also a very, very important thing that you need to keep in mind. You have to be very mindful. You cannot change the subscript. So here it is written NaNO3 and there are 4 oxygen atoms in the product side, and in the reactant side there are only 3 oxygen atoms. In order to balance that, you cannot be changing this. This is entirely wrong. Okay? Do not change the subscript. Do not change the subscript. Do not change the subscript. You can only change the coefficient. Change the coefficient. Change the coefficient. Okay? So do not touch the subscript. Change the coefficient. And let's solve the next one. So I'll put a table here. This is also pretty simple. Let's see. So potassium, chlorine, oxygen atoms are there. Reactant and in product side. Let me change the color now. So K, 1. And in the product side, 1. Chlorine, 1. Here, 1. Oxygen, 3 and 2. So 3 here, 2 here. So this KClO3 has the highest number of atoms. So let's consider that. Keep that in mind and try to balance the other. So we will be multiplying O2 by 2 here. Let's see what's going to happen. So 2 2s are 4 it is. Right? 2 2s are 4. And what else has been, changed? Nothing. But we'll try to, multiply KCl by 2. Let's see what happens. So if we multiply KCl by 2, so 2 in the product side, Cl in the product side, there are 2 chlorine atoms. Next, we'll multiply this. So what's going to happen? KClO3. So 2 potassium in the reactant side, 2 chlorine, and 3 2s are 6 oxygen atoms. Here there are only 4 oxygen atoms. So what do we need to do? We need to multiply oxygen by 3. Okay, we'll multiply this by 3. What is going to happen? 3 2s are 6. Everything is balanced. So 2 KClO3 gives 2 KCl plus 3O2. 3O2. Okay, so this is the balanced chemical equation. Whenever in the exam they ask you to write examples of any type of reaction or any reaction, please do make sure to write the balanced chemical equation. Okay, all right. I hope this is understood. Moving on, types of chemical equations. So in this lesson, in this chapter, we discuss. Let's see how many types of reactions. Total of 5 types of reactions. Okay, and there are 2 more based on the energy difference. How? We'll see. So first one, we are going to discuss about combination reaction, and then we are going to discuss about decomposition reaction. Decomposition reaction and combination reactions are opposite to each other. Next, we are going to discuss displacement reaction, and then we discuss double displacement reaction, and then we discuss redox reaction. And then we have endothermic reaction and exothermic reaction. Endothermic and exothermic reactions. And what are the indicators of a chemical reaction that's happening? So during a when there is a chemical reaction that's happening, what's going to be happening? See, indicators of chemical reactions. Obviously, chemical reactions are indicated by a new substance formed. Okay, new substance is formed. There is always a new substance that is formed. New substance is formed. Change in smell. Change in smell or odor. Change in smell or odor. Change in state might happen. Change in state. Change in state. Change in color might happen. Change in color. Evolution of gas. Evolution of gas. Formation of precipitates. Formation of precipitates. Precipitate. And not to forget, change in temperature. Okay. So the last one, change in temperature. It's not necessary that all the chemical reactions are indicated by all these changes. But there are two constant changes during a chemical reaction. That is the first one and the seventh one. So change in temperature, be it a big change or a small change, change in temperature is always going to be there. Okay, temperature is either, heat energy is either absorbed or released. Okay, and there is always a new substance that is formed. These two are constant. Okay, these two are constant changes or indicators. So moving on now, first one, combination reaction. So sulfur is reacting with oxygen to give sulfur dioxide. Very simple. See here, what's happening in combination reaction? So in a combination reaction, a single reactant, what is it? In a combination reaction, there are two reactants combining to form a single product. Two reactants combining to form a single product, or two or more reactants combine to form single product. Combine to form single product. Okay, that is combination reaction. So opposite to that of combination reaction is the decomposition reaction. Here you can see H2CO3. This is carbonic acid. It is going to give water and carbon dioxide. Okay, a single reactant breaks up to give two or more products. A single reactant decomposes to give two or more products. So in the exam, they might ask you a question. Why combination reaction is called opposite to that of decomposition reaction? The same answer. In combination reaction, two or more reactants are going to combine to form a single product. In decomposition reaction, on the other hand, a single reactant is going to decompose to give two or more products. All right. And these decomposition reactions are not going to happen just like that. So they need some kind of energy. So according to the kind of energy, type of energy, we have three types of decomposition reaction. The first one is the thermolytic decomposition reaction. So thermal or thermolytic decomposition reaction, where heat energy is supplied and the reactant is going to break down to form products. Here is an example. Magnesium carbonate, when it is heated, it is going to give magnesium oxide and carbon dioxide gas. And the second type is electrolytic decomposition reaction, where electricity is used as the energy. Electricity is also one of the forms of energy, right? So here NaOH, this is nothing but caustic soda or sodium hydroxide. When it is passed with electricity, okay. So the molten NaOH will be passed with electricity. It is going to produce sodium oxide, Na2O, and water. So this is an unbalanced equation. You need to balance this, okay. And then we have water. So when water is passed with electricity, when we heat water or when we subject water to ultraviolet light or sunlight, it is not going to decompose. It's not going to decompose to give hydrogen gas or oxygen gas. But when we pass electricity through water, it is going to produce hydrogen gas and oxygen gas. So this is a very important concept. Okay, so this is one of the most frequently asked questions. Explain electrolytic decomposition of water. So this is the electrolytic decomposition of water. This is super important. Next one, we have photolytic decomposition. Photon. What is photon? That is light energy. When not all the chemical compounds are sensitive to light, only a few of them are. So when we subject these chemical compounds to ultraviolet light or even sunlight, so what's going to happen? It is going to decompose to give the respective product. Here, ozone, when UV light falls on it, it is going to give oxygen gas and nascent oxygen. Just one oxygen, okay, oxygen atom, that is nascent oxygen or atomic oxygen. Meanwhile, similarly, AgCl, 2-AgCl, when UV light is passed, it's going to give 2Ag and chlorine gas, Cl2. Okay, here are some more examples. NO2. So on the top of arrow, if you represent delta, it means that it is heat. Okay, heat. Oxalic acid upon heating is HCOOH and CO2. Okay, CO2. And CaCO3 upon heating is CaO and CO2, carbon dioxide. So this is about combination reaction as well as decomposition reaction. In decomposition reaction, we have three types: thermolytic, electrolytic and photolytic decomposition reaction. Moving on to displacement reaction. So displacement reaction is a reaction where the more reactive metal displaces the less reactive metal. Displaces the less reactive metal. This is nothing but displacement reaction. Okay, here iron is displacing copper from copper sulfate solution to give ferrous sulfate and copper. How do we know the reactivity? This is the reactivity series. Okay, it is a series of or arrangement of metals in the order of their reactivity. Potassium is the most reactive one. Then comes sodium, calcium, magnesium, aluminium, zinc, ferrum, that is iron. Next we have tin, lead, copper, mercury, silver, gold. Last comes the platinum. So these metals are arranged in the order of their reactivity, how they are going to react with water, oxygen, other chemical compounds. And so whichever metal that is placed above in the reactivity series can displace the metal that is placed below in the reactivity series. Moving on to the double displacement reaction now. So yes, can copper displace iron from iron sulfate, ferrous sulfate? No reaction is going to happen because copper is placed below iron in the reactivity series. You have to remember the reactivity series. This is a very, very important concept. It repeats in the second chapter as well as in the third chapter. Okay. Moving on. So double displacement reaction, 2AgNO3. Here, exchange of ions is going to happen. Exchange of ions. So AB plus CD. So here, what's going to happen? A is going to combine with C and B is combining with D. Okay, AB plus CD gives AC plus BD. Exchange of ions. AgNO3 reacting with MgCl2. That is silver nitrate is reacting with magnesium chloride to give silver chloride. See here, silver and chlorine. Silver chloride. Magnesium nitrate. Okay. And here is another example, K2CO3, potassium carbonate reacting with ammonium iodide. Okay, it is giving potassium iodide and ammonium carbonate. Exchange of ions is going to happen. And double displacement reactions, the products sometimes are precipitates. Those are called precipitation reactions. Where precipitates are formed, these are called precipitation reactions. Not all double displacement reactions are precipitation reactions. The first chapter, you have discussed this NaOH plus. In the second chapter, you are going to discuss that NaOH is going to react with HCl. This is a neutralization reaction to give NaCl and H2O. See here, this is also a double displacement reaction. But there is no production of precipitate. So not all the double displacement reactions are precipitation reactions. Moving on, the last type here, redox reaction. So redox reaction, the name itself suggests here. So reduction and oxidation are going to happen simultaneously. Reduction and oxidation. So what is oxidation? Addition of oxygen or removal of hydrogen. Removal of hydrogen. So on the other hand, reduction, so addition of hydrogen, addition of hydrogen or removal of oxygen. Removal of oxygen. So if both reduction and oxidation reactions are happening simultaneously in the same reaction, those are called redox reactions. See here, vanadium pentoxide is losing oxygen to give vanadium. Okay, so it is losing oxidation oxygen means it is undergoing reduction. Calcium is gaining oxygen, which means that it is undergoing oxidation. So in the same reaction, both reduction and oxidation reactions happen. So these are called redox reactions. So both of these occur simultaneously. Occurs simultaneously. Next one, Pb3O4, lead oxide is reacting with HCl to give PbCl2, Cl2 and H2O. See here. So what's happening? Here also both reduction and oxidation reactions are happening. So these are called redox reactions. Okay, here is an example. Copper oxide reacts with hydrogen gas to give copper and hydrogen oxide, that is water. So what is this reaction? See here, copper oxide is undergoing reduction because removal of oxygen is happening, and hydrogen is undergoing oxidation. Hydrogen is undergoing oxidation. Okay, so there is also one more concept in the same, reducing agent and an oxidizing agent. So what is a reducing agent? Now that we have studied about reduction and oxidation, let's see reducing agent. Reducing agent is a substance which reduces the other itself undergoing oxidation. Itself undergoes oxidation. So in the first reaction, which is the reducing agent, itself undergoes oxidation, right? So calcium is undergoing oxidation. So this is the reducing agent. Calcium is it is the reducing agent. Vanadium pentoxide is the oxidizing agent. Why? So oxidizing agent is a substance which itself undergoes, the definition is ulta, okay, opposite. So reducing agent reduces the other. Oxidizing agent oxidizes the other, itself undergoing reduction. Okay, vanadium pentoxide. So it is the oxidizing agent. And I need all of you to comment down. Okay, comment down this. So which is undergoing reduction, which is undergoing oxidation in this reaction. Okay, and which is the reducing agent and the oxidizing agent. Okay, comment down. Moving on, corrosion. So corrosion is a type of redox reaction. What happens here? Corrosion is nothing but it is a natural process where the deterioration of metal surface happens. Okay, you must have seen rust, iron rust. Okay, so deterioration of metal surface. Deterioration of metal surface. That is nothing but corrosion. So rusting, corrosion in case of iron is called rusting. So 4Fe plus 3O2 H2O gives Fe2O3. This is nothing but hydrated ferric oxide. This is nothing but the rust, hydrated ferric oxide, the brown flaky substance. Then tarnishing. Tarnishing happens in case of copper and silver. Corrosion in case of copper and silver is called tarnishing. Black coating of silver is due to formation of silver sulfide, Ag2S. 2Ag plus H2S. So this is a very pungent, garbage smelling gas, hydrogen sulfide gas. So it is going to, react with oxygen gas to give Ag2S, okay, silver sulfide and hydrogen gas. And then we have, copper. When copper metal is exposed to the atmosphere, copper oxide, which has a red color, is produced when the metal reacts with oxygen in the air. See here, 2Cu plus half O2 gives Cu2O. So in the environment, this copper oxide is going to react with carbon dioxide, sulfur trioxide and water to produce the minerals malachite and blue, this copper hydroxide. Okay, this is called bronchitite. This is the cause of bluish green coloration of the copper. This is the reason for tarnishing of copper. So silver sulfide is the calls for tarnishing of silver, and basic copper carbonate. Basic copper carbonate is responsible for tarnishing of copper. Okay, basic copper carbonate. So moving on now, rancidity. So rancidity is also a natural phenomena, just like corrosion. Okay, corrosion happens in case of metals. Rancidity happens in case of foods containing oils and fats. When they are exposed to the air, they are going to undergo oxidation reaction. So they are going to be rancid, and these food items are unfit for consumption. Unfit for consumption. How can we avoid rancidity then? Packing the food properly. Packing the food properly. And nitrogen can be used. Nitrogen gas. Okay. Inside chips packets. Inside chips packets. Chips packets. In order to avoid this oxidation, because nitrogen is not going to react that readily with oxygen. Okay. So these are the natural processes. Rancidity as well as corrosion. These two topics are extremely important. Moving on with endothermic and exothermic reaction, we have come to the end of the session. So exothermic reaction, it is nothing but the heat energy is given out. Heat energy is given out. Okay, heat energy. Heat is given out or exit. Exothermic exit. That's how I remember. Endothermic reactions are those where heat energy is absorbed. Heat is absorbed by the reactant. Absorbed by the reactant. In case of exothermic reaction, how are we going to represent? See here, A plus B gives C. Okay, C plus D and heat. Here we are going to represent heat. Okay. In endothermic reaction, how are we going to represent? So A plus B, it is absorbing heat. So heat delta symbol will be represented upon the arrow mark to give C. This is endothermic reaction. This is how we represent. So the decomposition of ferrous sulfate is an example of an endothermic reaction because heat is absorbed during this reaction. Okay, so decomposition reactions are endothermic in nature. Not all, but thermolytic decomposition reaction. And then the dissolution of ammonium chloride in water is an example for endothermic reaction because heat is absorbed during this reaction. The dilution of sulfuric acid is an example of exothermic reaction. Why? A lot of heat energy is given out. Dilution of acids. And the dissolution of sodium hydroxide, NaOH, in water is also an example for exothermic reaction because heat energy is given out. It is given out. Okay. So this is all. So we have discussed a lot of things. That whole chapter under just 30 minutes, under 35 minutes. All right. So this is all. So for more videos like this, please do subscribe to the channel and turn on that notification. The notes of the same chapter will be available in the description. Click on that, enter your credentials and download that. Okay, it will be super useful for you. So until I see you in the next class, take good care of yourself and all the best for your exams. Okay, study well and keep supporting us. Bye-bye.